Hello everyone, Chip Plus once again with LCI Corporation. Today we're going to talk about thin film dryers again, and the topic is simple energy reduction. Now, in previous presentations, we talked about heat transfer and evaporation within indirect dryers. I suggest you go back and take a look at those before tackling this presentation. So with that, let's move on to the presentation. So let's talk first about basic energy usage with the thin film dryer. Over to the right, you can see the diagram of the thin film dryer with the rotor blade combination in the center. The rotor blade combination is painting the sludge, highlighted by the blue dot, into a thin film on the inner heating jacket of the thin film dryer. Inside the heating jacket is the heating medium that is transferring its heat into the sludge to evaporate the water. The very small or the very thin film created by that rotor blade combination creates a very small distance for that heat to have to transfer, and it's also continually refreshing fresh sludge and moisture onto the inner heating jacket. So that creates a very efficient drying process. With the thin film dryer, we can use less than 1400 BTUs per pound of water when we're partially drying, and when fully drying, that drops to less than 1200 BTUs per pound of water. That doesn't consider heat recovery. We can recover heat off the condensation system. That's typically in the form of hot water at about 190 degrees Fahrenheit, which can be beneficially reused for digester heating to preheat the sludge or for some other hot water need. So let's talk about a simple way to see energy reduction with thin film drying. That is by partial drying. In this case, we're going to dry for the process, and many processes like thermal destruction and landfilling don't require 90% solids. In the case of partial drying, we will use the same amount of sensible heat, but we will lower the latent heat because we're not evaporating as much water. You can see a 10 to 25% reduction in the heat requirement versus full drying when we move to partial drying. But we have to be careful when we compare BTUs per pound of water evaporated. The reason is, since we're using the same amount of sensible heat, but we're lowering the mass of the water evaporated, we're actually going to trick the metric into saying we need more BTUs per pound of water, and that'll lead people to think we're using more energy. Well, that's not the case because you have to look at total overall energy usage. And in this case, we're actually going to lower the amount of BTUs required by the process, and that makes sense because we're not evaporating as much water. So let's talk about why you can't always use the metric of BTUs per pound of water evaporated. On this chart, you see drying to different levels, from 45 to 65 to 90%. Over to the right, you see the typical metric of BTUs per pound of water evaporated, and you can see it goes up as we go lower in DS. But over to the left is a more accurate representation. This is showing you how much heat per wet pound of sludge that you're putting into the dryer. As you can see, we can significantly reduce the amount of heat needed when we partially dry as compared to fully drying. So this is a way of looking at that heat consumption versus throughput. There's a couple of different things going on this chart. First of all, looking at the blue line, that's amount of sludge, wet pounds per hour we're putting into the dryer. The orange line, that is the line showing the amount of water evaporated in pounds per hour. Now the bars represent heat usage. The gray bar is sensible heat, which is going to remain the same because we're heating the same amount of sludge. The latent heat actually is going to go down because the mass of the water evaporated is less at 45% than it is at 65 than it is at 90. So this shows you the real energy numbers, and you can see there's a significant decrease in energy usage as we drop from fully drying down to partially drying. Hi everyone, thank you for joining my presentation on energy reduction by partial drying. If you have any questions, please reach out to me at the contact information provided. Also, please follow, like, and subscribe to our social media.